Alright, this is the Python Team 4, and I would be explaining what we did in our program. Here we are looking at what we call the Telecommunication CDR Analysis, which stands for Call Data Records. And this team consists of Ongyen, Oludari, and Shinyan. So, what exactly is call data records? In the transaction of a phone call between a called person and a recipient, in between the telecommunication mast, there is what they call the switching center, which is pretty much the MITSO. Now, this collects all the call data records, and this call data records is all the informations that can be gathered based on this communication. Certain information could be the phone numbers, the time they spent, the costs, and all whatnot. Now, these informations are being used by different individuals in a telecom organization. First, we look at the network operation center, which pretty much do a proactive monitoring of the network. Next, we look at the network repair bureau, which actually repairs analyze faults and repairs. The change control config group actually does the pretty much maintenance, and the top business management, well, they deal with the cost. So we are going to be looking at all the files that we put together in the completion of this project. The first one I'll be looking at is the input file that we are going to be using, the data that we collected in order to that we actually want to analyze. I will put this over here. Now, this data consists of call data records, like I said, consists of the caller ID, which is pretty much the phone number. It consists of the called individual, which is the recipient, the call time, the time the call was pretty much initiated. This can be found also in the slide. And this is the connection time, the time in which the called party was connected. Here we looked at the time in which the call was initiation was actually dropped, and this could be as a result of maybe the number was unreachable, the number was busy. This is analyzed under the finished reasons, and it could also be because of network error. Now, network error is actually a critical part that will be analyzing in our data, and we will be looking at the duration. Duration is pretty much the finish time minus the connection time, and most importantly, well, cost actually drives the business, so therefore we'll also be analyzing the costs for each of the particular days. Now, if you look at our next slide, we are going to be looking at the analysis of our third of our library. Here we are going to be importing the CVS file itself, which is going to be which we defined in this kind of function. And here one thing we would like to note here is that we removed the heading, which is actually this, so that we can have the same format of data in each of the columns. And we decided to create functions for each of the analysis that we are going to be doing. Like I said, we are doing 4 different analyses. The first, before going to the first one, here we define a class, a class called call, and we put in functions for each of the variables and a getter value for each of the variables that we're going to be using. Here, remember, we did a time zone. We divided each time by the day. We divided each time by day, evening, and night call. So between the hours of 6 and 15, which is 3 p.m. Remember, we are using military time. If you look at the data we have here, one thing I want us to take note of is between. First thing is this date is actually in it's analyzed by the day, the month, and the year. Now, this contains the time, and between the 11th data and the 13 data of the connection time, we do have the time. And if we have a time that falls between 6 and 13, which is 3 p.m., that's classified as day. If it falls between 15 and 23, that's classified as evening, and all others is classified as night. For the cost, if it's an empty column, it's pretty much zero, and this is based on the fact that it was either unreachable, or it was busy, or it was a network error. First analysis, we analyzed the network error, looking at the entire calls that were being made, how many network error occurred, and the percentage of network error. Here we looked through the list and we created a counter and we imputed the counter. Percentage rate would be total error divided by total cost in percent. Now the second analysis that we did was looking at getting each of analyzing the number of total network error per day. So this is pretty much different from what we did at the first one. The third analysis we did is actually call reason analysis by time zone. How many calls were made during the day, evening, and night? This is necessary to look at when people make the busiest hour of the day, when people make calls the most, and we plotted it in a pie chart, which we're going to be showing you in a second. And finally, we analyzed each call by the day of the week: Monday, Tuesday, Wednesday. Like I said, this data actually contains only 8 days data. We classify the first day and the 8th day as actually Sunday, while every other day follows the same format. Day 2 for Monday, day 3 for Tuesday, and all the rest. And we are going to show you a printed value of the total seconds that was being of calls being made, and the total cost. Here we labeled it Monday, Tuesday, Wednesday, Thursday, and we are going to be creating a pie chart for this analysis. Now let's look at our major program that we actually designed. I'm going to put this away, and the major program that we designed. Now we gave people the whoever is going to be running this program, you have the option of A, B, C, D to choose of each of the analysis. And if you enter after each of the analysis, you can easily say, okay, you can continue to run this program, or you can end the program if you want to. So the first thing we did here is, let's actually do a quick demo. We run this program, it welcomes you and tells you which of the options you want to take. Choosing A, enter, it tells you the entire error rate. From this data, we looked, like I said, we looked through the entire entire list and counted the error rates, and we got a total of 88 error rates, and this brought us to about 8.8%. Total calls, like I said, is 1000 altogether. This 1001, but minus this will give you 1000. And let's continue our analysis. We go to B. Now B, like I said, allows you to classify the network error based on time zone. Is it day, evening, or night? And one thing I would like to show you in this program is that you can either print the result, or you have the option of actually outputting it into a file. Here this explains it. Here you can either output the result into a file, which is what we're gonna do here. If you select F, okay, if you select F, that's tells you what is the name of the file you want to output it to. So let's type team4, enter, and that gives an output to team4. Here is our folder, and team4 Here's our output. So we have 32 network errors in the day, 34 in the evening, and in the night is 22. Altogether, you should have 88, and this is the percentage rate for the total network errors. Now let's continue our analysis. We go to C. Now, C is actually the total number of calls per time zone. 370 calls were made during the day, 331 evening, and 399 at night. This is necessary for you to be able to plan when you can do changes within the network or change controls within the network. Now, the nights is classified as the time that people don't usually make calls. Well, this is pretty much a high number, but like I said, this is a dummy data. At the same time, we have a figure, we have a pie chart that this outputs and tells you the percentage by day, nights, or evening. And we had different color gradings. I'm gonna close that. We had different color gradings for each of the day, evening, nights, thanks to third-party library that we imported here. That's matplot library. And finally, I'm gonna close this figure, and finally we are going to say yes to this and run the last analysis, which is this. Now we looked at each of the calls and analyzed how many calls were made from Monday, how many calls on Tuesday, Wednesday, like that, and down to Sunday. Sunday pretty much is a high number. Why? Because we combined two days together. That's the first day and the 8th day. Remember in this chart I showed you that the connection in the under connection time, we only have day 1 down to the maximum day we had what was day 8. So the total number of seconds we have here, the total cost, and pretty much it was a uniform cost of 0.3 if you want to say 0.43 cents per second. Well, it's a dummy data anyway, so this gives you a pie chart. So that explains all the data we analyzed from this. And remember one thing: network error is necessary for checking the network efficiency of your network, and this is also necessary for planning. Do you need to increase because of the high number of calls we have during the day? Do we need to increase support staffs available? Then you can look at which the days of the week, which day is actually the busiest. So like I said, this can be used in large corporations as good as Verizon Wireless, AT&T, T-Mobile, and even international companies. So that brings us to the end of our program called the Telecommunication Call Data Record Analysis. Thank you very much.